In this video, we're going to talk about the AP Calculus AB exam from 2010, FRQ question number 4 from Form B. So this question, kind of a crazy story here. A squirrel going along a straight line, connecting two buildings, and we have the velocity graph. And part A says, at what times does the squirrel change direction? And we know that we have a change in direction if velocity changes sign. That happens here at t equals 9 and here at t equals 15. And so we have to give a reason, so we will just say exactly what we just said. Part A. T equals 9 and t equals 15 because that is where velocity changes sign. Okay. Part B, at what time is the squirrel farthest from building A? And then how far is the squirrel? Essentially what we're looking for is the maximum distance. The maximum distance from building A. So that distance that the squirrel travels, or really displacement here, we want to know how far from his starting place, which was at building A. That's just going to be the integral of the velocity that's going to give me my displacement. And I want to know, well, where could we be the farthest? And anytime we're thinking about the farthest, the most, the biggest, the least, the smallest, any of those optimization, those maximums, those minimums, we're looking for either critical numbers, which we just identified as 9 and 15, or endpoints, which are 0 and 18. Now, certainly we know that at t equals 0, that's not the farthest from building A because we're at building A. 9 is a definite candidate because this whole time we're traveling away from building A, and then at t equals 9 we switch and we start traveling back towards it. So 15 is not really a candidate because that's a relative minimum. We're going closer to building A this entire interval from 9 to 15. So the only real candidates are either 9 or 18. And so we could simply find those values. I know that what I'm looking for is the integral from 0 to 9 of v of t. And that's just the area underneath that curve, which is a trapezoid. So it's 1/2. 9 is my base 1, and 5 is my base 2. Just looking at my trapezoid here, this is 9, this is 5. And then my height is 20. And that is going to be 140. And my next candidate is the 18. But I'm also going to think about this little chunk right in here because I know, okay, so now I'm at 140 units from building A. Now I'm going to go back some number of units and then forward again some number of units. So I'm going to write in here, this is 140. And if I do a little math here again, this next trapezoid, let's just write some stuff on here. This distance from 10 to 14, that's 4. This is 6. And then the height here is, of course, given to us as 10. And really negative 10. So we have 6 plus 4, cut it in half. 5, so we have 50 here, and really negative 50. And then up top, we've got another one. You could think about this as a triangle and a square, or triangle and a rectangle, rather. But to me, the trapezoid is just easier. So we've got a height of 10, we've got a base here from 15 to 18 of 3, and then another one of 2 from 16 to 18 there. So 1/2 times 3 plus 2 times 10 is 25. Right. So we go forward 140 units, backwards 50 units, so now we're at 90 total units from building A, and then we go forward another 25 units, meaning we're at only 115 units. We haven't, this isn't enough positive area to make up for the negative that we went backwards here. In this problem, how far, or at what time, and how far? So our answer is just 140. My units are what are my units here? Squirrel's velocity. Does it give us units? That's weird. No, it doesn't. That's weird. As 140 units at t equals 9. Doesn't ask us to justify. Now, we had to go through this to figure it out for ourselves, but it doesn't ask us to write any of that down. And now part C is the total distance. Well, that's just saying don't let this count as negative. Just think about that as total, as distance traveled here. So we're just going to add all these up, treating this one as positive. So for part C, I'm just going to sneak it over here. For part C, we've got 140 plus 50 plus 25, all added up, giving me a total of 215 there for part C. A little crowded, I know, but I think we got it. All right. I'm going to get rid of all that, so if you need to pause it, write it down, go for it. All right, so in part D, we want an expression for acceleration, velocity, and distance from building A that are valid for the time interval from t equals 7 to t equals 10. So this little chunk here. So this is my velocity function. That's what this is the graph of. So I just need to come up with an equation for this line to get my velocity function, and then the slope of that line is the acceleration. So I'll start with the acceleration because it's just the slope of that line. So for part D, A of t is going to be slope, and if you just count, right, we're going from positive 20 to negative 10, and my change in y is 30, down 30, and I'm going from 7 to 10, so that's a change in x of 3, so it's negative 30 over 3, which is negative 10. It's a constant rate of change there. So A of t is negative 10. V of t is just going to be my sort of linear function there, and I'm just going to think about that in terms of point slope form to start. So y2 minus y1 equals m x2 minus x1. Oops, not 1x. Right? And then I'm just going to leave the y2 as y minus, I'll use the first point. 20 equals negative 10 times x minus 7. I do have to move this 20 over because I'm looking for a function where this y represents v of t, the output of that. So I'm going to move that over and then change it to a v of t. So v of t should be negative 10 times x minus 7 plus 20. And I can leave it like that. If I was stopping here, I would just say leave it like that. There's no reason to go any further. But because I'm going to need that function to get my position, my distance from building A function, I'm going to go ahead and distribute and kind of simplify this a little bit and say this is negative 10x, and then that's going to be positive 70 plus 20, so that's going to be plus 90. So that's my velocity function. Now, to get to position, there's a couple ways I can think about it, but I'm just going to say, well, position should be the antiderivative of velocity. So let's do that. So x of t is then, and I guess this should have been a t, not an x, sorry. T. So negative, if I take the antiderivative here, it's going to be negative 5 t squared plus 90t plus c. And to figure out that c, I have to know some input-output pair, t and position, that's valid between 7 and 10. And so what I do know, if I come and look at what we did from before, we know that at time t equals 9, the distance that we were from building A is 140, right? So I have that input-output pair, which is valid on this interval. So I'm going to swipe this back up and say, okay, the position from building A, the distance from building A is 140 when t is 9. That will then allow me to find that c value and then write out my equation. If I do the arithmetic here, we'll get c equals negative 265, I believe. And so then my function is negative 5t squared plus 90t minus 265. And we're all done.